Good morning, good afternoon, good evening. Thank you for joining us today. I'm excited to share with you a groundbreaking project that aims to address critical issues in wildlife conservation. Our project revolves around understanding and analyzing distress calls of elephants using CNNs. So, what we're going to do is we're going to differentiate the elephant calls from a 24-hour 16 kilohertz audio dataset, extract those elephant distress calls, and the background noises and feed into a convolution neural network to understand, to train the model. So when we load the model, we can make sure when we insert a 24-hour 16 kilohertz audio files from an acoustic recorder, we can identify a potential distress call. If we can do that, we can integrate those CNN models to a geospatial data, and we can assign markers from where the acoustic recorders has been taken from. So this creates a potential hotspots. When you mark the acoustic recorders, this creates a potential hotspots around the acoustic recorders, which can be used to provide more security and monitoring to ignore the potential threats for the elephants, for their bushmeat and tusks. So let us dive into the project. This project ensures that complex audio recordings and accurately detect distress calls using leveraging the CNN. So first, let us import some dependencies. These are the dependencies, and I've included the path for the data. We obtained this data from elephant listening project in the Congo rainforest, which includes numerous audio data files of forest recordings, which includes elephants too. So I've loaded and leveraged some pre-processing techniques for audio files just using the TensorFlow library and created the dataset. By using the TensorFlow dataset function, we can create data pipelining, which can be useful for an ideal data to import into a CNN model. So let's calculate. I've calculated the wavelengths and the lengths to test separate the train test split. I've used some mathematical equations to divide the audio datasets, and I've pre-processed using a function which converts normal audio files into spectrogram. Actually, this spectrogram is a pictorial representation of the audio files. So we are actually detecting the audios and pre-process and transform it into an image, so we can use an image classification. File path labels converted into a spectrogram, and I visualized it. Next, I'm creating training and testing partitions. So our length of data contains 20 files per batch. So I've separated it 14 and 6 for test. So I've labeled it, and this is the deep learning architecture, which focuses on creating sequential data converted using 4, 5, 6 layers, convolution 2D layers, which allows a filter to glide around the image, find features. I've flattened it, I've densed it, and finally using sigmoid function, we've acquired binary classification. I've used Adam for cross verifying and binary cross entropy for loss identification, and some metrics which used for a typical binary classification as recall and precision. And this is the model summary. Trained it. There are 4 epochs. Visualize the loss, precision, and recall. As we can see, we get output as labeling 10000. So what this says is 1 represents distress calls and 0 represents background noises. So by using this, we can identify a potential distress calls in audio recordings, and from audio recordings we can mark them into a geospatial data and find the potential hotspot and provide more security. Thank you.